In this first example for constructing a confidence interval around the difference between two sample proportions, we're going to use data from the previous tutorial where I demonstrated how to construct proportions around a single sample estimate. And in this case, what we're looking for will be the difference between the proportion of our sample that supports Clinton versus the proportion of the sample that supports Trump. Just a refresher, these data come from the Marquette University Law School poll that was administered October 26th through 31st in 2016, just before the 2016 presidential election, and it's a survey of about 1,189 likely voters. What we see here is 544 indicate they would support Clinton if the election were held today, as compared to 470 who indicate they would support Trump. And we're just going to compare then the two sample proportions, support for Clinton and support for Trump. Now, one of the things we want to ask now is, what is the difference between the two? And is there a statistically significant difference? Or is one candidate have a statistical lead? Or instead, would we assume, based upon these data, that there is no clear lead between these two candidates? The first thing we'll do is to compute the proportion, or the p hat 1, I'll call it, for candidate 1 or option 1, support for Clinton, equal, click on the cell that contains the frequency who said that they would support Clinton, 544 respondents, divided by the total sample size. And we'll do the same thing for Trump. Take 470 divided by the total sample size. And that's what we need to compute first in order to compute now the margin of error. So let's go ahead and compute the standard error. On the previous slide, I showed you what the formula is for when we're comparing responses within the same question of a survey. And in this case, what we're going to do is take, and I'm going to put in, in parentheses, the proportion that indicates support for, let me start that again, equal. Now the parenthesis open. Proportion indicate they would support Clinton, or p hat 1. Add to that the proportion indicate they would support Trump from the sample, or p hat 2. Close that in parentheses. Subtract that from now p hat 1. And I'm going to square then the difference we see in that second parenthetical statement of p hat 1 minus p hat 2. Now I'm going to take that entire formula so far, and that's just going to be the numerator for the standard error computation, and I'll divide that then by the total sample size we see here in B12. Now keep in mind, we now also have to take the square root of this entire value. I'll hit return, and there we see a standard error of 0.027. Now I'm going to put in 95 for the 95% confidence level, and of course we could change this if we wish. A probability value then is going to be 0.05. We'll find that by equal 1 minus, and in parentheses I'm going to take now the confidence level of 95% and divide that by 100 to get that into a proportion. So 1 minus 0.95 will result in 0.05. The critical values then we'll find again with the norm.s.inverse command or function in Excel, norm.s.inverse or INV, and that's going to be 1 minus, and I'm going to take our probability value of 0.05 and divide that by 2. Keep in mind, confidence intervals always have some of the interval above and some of the interval below then the sample estimate. So that's why we divide 0.05 by 2, so 0.025 extreme right-hand proportion of the curve and 0.025 extreme left-hand portion of the normal standard distribution will be outside then this confidence interval. Hit return. Now to find margin of error, as we've done before, it's nothing more than the critical values. Multiply that then by the standard error. Now we have all the information we need. We see a margin of error is plus and minus 5.2% or 0.052 proportion. We have everything we need to construct then the confidence interval around the difference between these two candidates. So what I'm going to do now is first of all find the difference between these two sample proportions equal. I'll take the first one, p hat 1, subtract from that p hat 2. And there we see Clinton received about 0.062 proportion of the sample more support than did Trump. Now define the confidence interval constructed around that difference for the lower limit equal, and click on that difference between the two p hats, two sample estimates, minus the margin of error. Now for the upper limit for this confidence interval, again I'm going to click on the difference between the two sample proportions, and now I'm going to add to that the margin of error. And there we see that our sample, we see 0.062 proportion more supported Clinton than Trump. Using a 95% confidence level, we would indicate then that the population from which this sample likely was drawn ranges anywhere from 0.01 proportion more in support of Clinton than Trump up to 0.115 proportion more for Clinton than for Trump. Typically we report this information, these intervals, in percents. So let's go ahead and multiply our difference by 100 to get a percent. I'll click and drag that down. And now I'm also going to take the margin of error and multiply that by 100 to report it as a percent. So we see then that this confidence interval constructed around the 6.2% difference between Clinton and Trump actually has a margin of error of 5.2%. Now, if we look at the lower and upper limit, because 0 is not contained in this, we would say then that this sample likely came from a population where Clinton does have a statistical lead over Trump. What we have before us are data from a Gallup poll asking respondents about whether or not they approve or disapprove of the job that President Trump is doing as president. In both cases, the samples were 1,500 adults. And we noticed during the first time period, June 11th through June 17th, 45% indicated they approved of President Trump's job performance. And that figure fell to 40% for the period July 23 to 29th. What we're going to do here is ask whether or not that decline from 45% to 40% job approval is statistically significant, a statistically meaningful drop, or is it one that's just a function of random sampling variability. We're going to have to use a different formula this time for computing the standard error. And what we'll do here then is ask, does the 40% approval when compared to 45% approval indicate a substantial change in attitudes? So let's first of all then compute the proportion of respondents in each of these two time periods that indicated they approve of Trump's job performance. So for p hat 1, it's going to be equal to the frequency of respondents that approve divided by the total sample size. And next, we'll do the same thing then for the second time period, which we'll call p hat 2. Now we'll go ahead and compute the standard error. And what we're going to do here for the standard error, going back to the formula I demonstrated before for difference between two samples, is we'll have to take, first of all, the proportion that indicated they approve of Trump's job performance in the first poll times 1 minus that proportion and divide by the sample size from that sample. Now we will then add to that that same information now for the second time period. And again, divide by the sample size for that poll. Now this entire formula then we'll put in brackets, in parentheses, and we'll take the square root of that. And that's what we have there, a standard error of 0.018. Now next, for a confidence level, I'll keep a level. For the probability value then, as we've done before, 1 minus the confidence level divided by 100 to put it into proportions. So that's a 0.05. Now define the critical values for z equal, we'll use the norm.s.inverse function in Excel. 1 minus, we'll take the probability value and 1 minus the probability value and divide that by 2, because confidence intervals always are two tails, and we get plus and minus 1.96 for the critical values. Now define the margin of error. It's nothing more than the critical values multiplied by then the standard error. And there we have a margin of error of plus and minus 0.035 proportion. Now we have all the information we need to construct the confidence interval around the change from the second to the first. What we're going to do here is take the first time period, and that will be actually our second proportion in this formula. So I'm going to take p hat 2 minus p hat 1. Typically when we ask about a change in time, we use the most recent time and subtract then the prior time from that. And there we see a drop of 0.05 proportion from time period 1 to time period 2. Now the lower limit then for our confidence interval, nothing more than that difference we just computed of minus 0.05 proportion. Subtract from that our margin of error, and then the upper limit again will be that difference in proportion. Now we're going to add to that then the margin of error. And there we have our lower and upper limits. Now typically what you'll see is people report confidence intervals and responses to public opinion surveys in percents, not proportions. So let's just convert our information to proportions. So I'll take the difference, p hat 2 minus p hat 1, that's the change over time, and multiply that by 100. And now I can just autofill that formula down to the next two cells, and we see then our confidence interval from minus 8.5% up to 1.5 percentage points. The margin of error is going to be equal to nothing more than the margin of error times 100. Now we have the information in percentage form, and this indicates that while we saw between these two samples a 5 percentage point drop in job approval from June to July, these 2 weeks, the confidence interval constructed around that sample estimate, or that sample difference, indicates then it's likely, using the 95% confidence level, that these two samples came from populations where there actually is anywhere from a 8.5 percentage point drop from June to July up to a 1.5 percentage drop in approval ratings from June to July. Because 0 does not fall within this confidence interval, we would indicate that that is a statistically significant decline in job approval from June 11-17 through July 23 to 29. For this last example, what I have are data from the General Social Survey from 2016, where respondents were asked the question, do you think the use of marijuana should be made legal or not? What I've done is broken responses down by men and women. One way in which we can think about these data Even though these are data collected with the same survey, we can think of men and women as being two separate groups or two separate samples. So we can still then use the same formula for when we have independent samples for constructing this confidence interval around the difference in support for men and women. Let's first of all compute the proportion of men who indicate that marijuana use should be made legal. So I'll take equal, and I'll take the cell of men that offered that response by the total number of men, and I'll do the same thing now for women. Now to compute then the margin of error, what I'll do is first of all generate the standard error, and that's going to be p hat 1 times 1 minus p hat 1, that divided by the sample size for men. I will add to that then p hat 2 times, in parentheses, 1 minus p hat 2, divide that by the sample size for women, and that entire formula now, I will find the square root of that result. And we see a standard error of 0.022. Let's again stick with our standard 95% confidence level. The probability value is going to be 1 minus, and I'll put in parentheses here, 95 divided by 100. Parentheses aren't necessary there, but I'll just do that in this case. Now I'll use the norm.s.inverse command or function in Excel to find the critical values associated with the 95% confidence interval from the standard normal curve. And the probability value is going to be 1 minus, and it's going to be our p-value or alpha level divided by 2 is what we input here. And that's 1.9 plus or minus 1.96 should be the critical values for the z when we have a 95% confidence level. Find the margin of error, nothing more the critical values of z multiplied by the standard error, and we see it's plus or minus 0.043 proportion for a margin of error. Now we have everything we need to construct the confidence interval around the difference between these two samples. So to find the difference, I'll take men proportion offering that response, subtract from that women proportion. The lower limit is going to be equal to then that difference of the two proportion, subtracting from that the margin of error. And the upper limit again is going to be that difference between the two sample proportions, the two subgroups, but now I'm going to add the margin of error to it. And now what I'm going to do is convert our information for the confidence interval to percent, which is not necessary in this case, but we can. It's common to report this information percent, as well as the margin of error. So this confidence interval has a margin of error of plus or minus 4.3%, and we indicate here then that men, 3.1% of men, fewer men are offer the response marijuana should be legal as compared to women. Based upon the 95% confidence level and our sample attributes, then it appears then these two subgroups were drawn from a population where anywhere from 7.5% fewer men offer that response than women, percentage points men than women, as compared to men, 1.2% of men offer that response more than do women. So since 0 is contained here, we would say that there is not a statistically significant difference in the proportion of men that offer that response that marijuana should be made legal as compared to women. Now, the way in which I've constructed these confidence intervals throughout both of these tutorials on proportions is I can now, though, change the confidence level and compute a new confidence interval. Let's assume we had a 90% confidence interval. In that case, our margin of error would be plus or minus 3.6%, And we still see that because 0 is contained between the lower and upper limit of these two intervals, of this interval rather, that there is not a statistically significant difference in responses between men and women.